So, without wasting much time, we should directly come to the answers of the quiz that was conducted last week. So, concerning electromagnetic rays, the first STEM question that was asked was that they travel parallel to each other in the straight line, and the answer to this is false because electromagnetic rays originate from a point source and diverge out, traveling in a straight line. However, they are not parallel to each other unless they are attenuated. So, this was the parallel word was the thing which made this STEM question wrong. The beam intensity is proportional to the square of the amplitude. It is true. It is something which you have to just remember, that the beam intensity is proportional to the square of the amplitude of the electromagnetic ray. Third was the area of the beam is proportional to the square of the distance as it travels away from the point source. It is true because the inverse square law states that the intensity of the radiation emitted from a point source, as seen in this particular diagram, will reduce in intensity proportional to the square of the distance from that point. That is, the area covered by the beam increases. So, as we are seeing in this diagram. The fourth STEM question was beam intensity is proportional to the square of the distance as it travels away from the point source. It is false. This particular beam inverse square law does not have any relationship to the intensity of the beam. It is just the area increases, but not the intensity increases or decreases as per the square law. So it is not proportional. The answer is false. The inverse square law is useful for estimating the intensity of a beam once it has passed through a copper filter. So the answer is false. Why? Because whether the beam is passing through any filter or is not passing through any filter, that has nothing to do with the inverse square law. So the answer is false. The inverse square law remains as it is for any electromagnetic ray, even if it passes through a filter or not. So, regarding which of the following are true with regard to X-ray photon production? So, the first question or the STEM question asked was the area of a continuous spectrum graph represents the total output of all X-ray photons emitted as a result of characteristic radiation. The answer is false. Why? Because the area of the continuous spectrum, we all know it consists of both the Bremsstrahlung as well as the characteristic radiation. So, increasing the tube voltage, that is kV, results in continuous spectrum shifting to the right and the line spectrum increasing in height. So answer is true, because as we increase the tube voltage, it increases the frequency of the photon production as a result of the characteristic radiation. However, it does not influence the photon energy. The STEM question 3 asked was 1/4 of the photons from Bremsstrahlung radiation that reach the patient are less than 20 keV. So the answer is false. Why? Because first thing is 1/4 of the photons may not be of less than 20 keV in the Bremsstrahlung radiation. And the second was that less than 20 keV photons are usually absorbed by the glass tube itself. So uh, the answer is wrong, is false. Increasing the filament voltage causes Bremsstrahlung radiation graph to increase in height. So the answer to this is true, because increasing the filament voltage will definitely, as you know, will increase the number of the electrons colliding with the target material, causing an increase in the number of the photons produced by both characteristic as well as the Bremsstrahlung radiation. However, just remember that in the case of characteristic radiation, the intensity or the energy of the photon will not increase, because that is dependent on the material which is producing that characteristic radiation. But that may not be the case with Bremsstrahlung. Now, reducing the fifth question, the reducing the filament voltage has no effect on the maximum photon energy produced by characteristic or Bremsstrahlung radiation. The answer is again true, because filament voltage does not influence the photon energy in either characteristic or the Bremsstrahlung radiation. Coming to concerning the interaction of X-ray photons with matter, the first question or the STEM question was, it is possible to predict the fraction of photons that will be absorbed or scattered when passing through a given material. The answer is false, because the X-ray absorption, scatter are all like non-deterministic, or you can say stochastic processes. So we cannot predict whether which photon will be absorbed or which photon will be scattered. The attenuation is represented by the number of photons absorbed or scattered by a matter. The answer is true, because attenuation is all, as we know, is absorption plus refraction and reflection. So that means scatter as well as the absorption. Scattered photons help form the primary image on the film. So the answer is false, because the X-rays transmitted through the patient form the primary image, while the scattered X-rays obscure it. So they are the cause of more mottling or the noise. The fourth question asked is the half value layer of a material is the thickness needed to reduce the number of photons in a beam by half. Okay, so here it was a word play. It is not the reduction of the number of the photons, but it is the intensity of the beam that gets reduced by half. So the half value layer is the material of the thickness which is needed to reduce the intensity of the beam by, or the average energy of the beam by half. The half value layer is inversely proportional to the linear attenuation coefficient, that is LAC of the material. So the answer is true because the LAC, that is the linear attenuation coefficient, is the probability that a photon will interact with that particular material per unit length it travels in a specific material. So here the greater the LAC, the lower will be the half value layer. Also, there is something known as mass absorption coefficient, linear absorption coefficient. So you may be aware that mass absorption coefficient is nothing but linear absorption coefficient divided by the density. So just for your knowledge sake, concerning picture archiving and communication systems, typically only one archive is used for image storage. The answer is false because usually it's more than one archive that is used. A short term archive that exists for rapid accessing, a longer term archive that exists when the images are still available, but the accessing them requires a little bit longer period. So it is just a diagrammatic representation. The PAX flow manager is responsible for the retrieval of the images from the archive. The answer is yes, true. The PAX workflow manager is the one that is responsible. For effective functioning, PAX requires connection with the hospital information system. Yes, better the connection and better the integrity or integration of these two systems, the better and the effective functioning will be there. PAX is dependent on HL7 standard for information transfer from the hospital information system. True, because like HL7 is a system, as you will read it in Wikipedia, as I also got to know about it from that is health level 7. It's a standard for the transfer of information regarding patient demographics, results, as well as information from hospital system, and it helps in integrating all the systems together. So it is dependent on HL7 and the statement is true. Fifth statement, the cost savings compared with hard copy storage are definite. So the answer is false because although there are costs associated with film and the storage are removed in case when we put packs in our hospital, the cost of the maintenance of the packs, the cost of the upgradation of the packs, and various talks that happen between us and the vendor or the software companies are something extra. So these things are not definite. Like we cannot say that we will save this much. So the answer for the fifth question is false. It is just just a table just to say that yeah, I have a reference for this particular question, that the cost and effects of packs are variable in each system. With regard to radiation protection, that is fifth question now. With regard to radiation protection of the staff, the main radiation dose to the staff in the room is from the leakage of the radiation from the X-ray tube. Not at all, because if that is the case, then AARB will not even approve that X-ray tube. So leakage radiation from the X-ray tube is less than 2% of all the dose received by the staff in the room. And the scattered radiation from the Crompton interaction with the patient is the main radiation dose to the staff. So we should remember that. Standing close to the patient avoids scatter within the room and hence reduces the radiation dose. Not at all, again, because the nearer you are to the patient, the higher chances that you will be getting more scatter radiation. This is just a graph I have put that at various heights what is the level of the scatter radiation produced. So the most of the scatter radiation is produced, or the highest 100% of the scatter radiation intensity is most at the level of the patient. So it's better to wear an apron and as well as stay away from the patient as much as possible. Wearing lead apron protects against the primary beam. No, the major role of the lead apron is to protect yourself or protect you from the secondary scatter radiation. As per AERB, the equivalent dose to the lens of a classified worker should not exceed 150 millisieverts per annum. That is true. The equivalent dose limit for the lens of a classified worker should not exceed 150. Lead goggles can protect against cataracts. Yes, again, lead goggles are used by interventionists to protect them against cataract. Coming to the sixth question, there is factors affecting image quality. Increasing the MA will increase the quality of the image. True, because increasing MA, you know that it increases the signal to noise ratio at the expense of increasing dose to the patient. So if you increase MA, definitely the dose to the patient is going to increase. However, the quality also improves. Increasing the grain size within the film improves the resolution. False. Why? Because larger grains means that there will be less number of grains in a particular area or a particular volume, and therefore Therefore, it will be difficult to distinguish between two optical density changes of a certain area. So definitely that will reduce the resolution. Increasing crystal size within a screen decreases the resolution. Again, the answer is true, because larger the crystal size, it will emit more photons, and that's why it will have the potential to travel in multiple directions. This will decrease the unsharpness. This will increase the unsharpness. So increasing crystal size within a screen decreases the dose. It is again true. Why? Because larger the crystal, it will emit more light photons than a screen of the same thickness with smaller crystals, and therefore it will help us in decreasing the dose at the expense of resolution. Increasing the kV decreases the probability of photons interacting within the target. True, because the probability of the photoelectric effect decreases with the cube of the photon energy. This one should remember. This is one formula which is given in physics books. So the Compton scatter does not change significantly with increasing photon energy. However, the probability of the photoelectric effect decreases with the cube of the photon energy. Quality control in radiology. In carrying out quality control tests of the X-ray equipment, KV can be measured with a film sensitometer. Actually, it is false, because KV can be measured directly by KV meter, something which we call it, or penetratometer or potentiometer. The actual KV should be within 55%. That's what they say, like what is being measured and what is being produced, or what is being said to be produced by the X-ray tube. The timer accuracy is measured with an ion chamber. Actually false again. Why? Because an ion chamber measures the dose and not the time. For time, I don't know whether you have seen in on our table viva, we had one spinning lead top, which was the particular device which is used to measure the time of the X-ray production. Uh, Statement C, a spatial resolution of 12 line pair per centimeter would be acceptable for a fluoroscopic image intensifier barium examination. The answer to this is true, because fluoroscopy with an image intensifier TV achieves a spatial resolution of 1 line pair per mm. So 1 line pair per mm is approximately 10 line pair per centimeter, and so 12 line pair per centimeter is quite acceptable. At 80 kV, a half value layer of 2.8 mm aluminium would indicate adequate filtration. Again, the answer is true, because except for the mammography and some dental units, usually we use 2.5 mm aluminium to filter the beam. So 2.8 will definitely do a better job, or will cause an adequate filtration. Uh, Film screen, the statement 5, film screen contact is tested with a resolution grid inside the cassette. So the answer is false. Actually, I don't know whether you have seen all these quality control apparatus, but here we have a mesh, a perforated metallic mesh, which is being used, which is kept over the cassette to test the film screen contact. So the answer to this question was false. Coming to which is the following are correct regarding the stochastic effect of radiation. They can be hereditary in nature. True, because they may occur in descendants of individual exposed to a result of lesion. So yes, being non-deterministic, they are hereditary. They arise as a result of chance. Again, yes, because there is more. It works on the principle of probability. So they result as a result of chance. Statement C, that is the probability of the effect increases with dose. Again true. Higher the dose, higher the probability, or higher the probability that there may be a DNA or RNA involvement. Increasing the dose results in an increase in the severity of the disease. False. Why? Because since they are more probable, either the effect happens completely yes or completely no. So increasing the dose will have no role to play in the increase in the severity. Statement 5, there is no threshold dose for stochastic effects. Again true, there is no threshold dose. It works on the principle of probability. Question 9, regarding image intensifiers in fluoroscopy, the diameter of the input screen is usually twice the diameter of the output screen. The answer is false, because usually it ranges from 8 to 10 times the size of the input and the output screen, as seen here. So the intensity of the second statement, the intensity of light produced in the input phosphor and the number of the electrons produced by the photocathode are directly proportional to the intensity of the X-rays. It is true, because the more the number of photons that will be put over the phosphor, the more the light will be produced. and the more electrons production. The sequence of interaction in an image intensifier tube is X-ray, electrons, light, electrons. So the answer is false, because here the sequence, as I can show you in this particular image, it is X-rays, light with the help of input phosphor, electrons, and then light. So the sequence is X-ray, light, electrons, light, not X-ray, electrons, light, electrons. So that statement is false. Absorption of X-ray photons in the input screen window should be kept to a maximum. Actually, input screen is devised in such a way, it is just to give mechanical strength and to maintain the vacuum. So the attenuation that should happen here from the X-ray should be minimal. So that's why the answer to this question is false. The vacuum tube is filled with ionized gas. Again, it is false. It is a vacuum. The regarding image intensifier, the fluoroscopy tube is filled with gas. No, it is not filled with any gas, because that will hinder the movement of the electrons. So it's a vacuum tube. Regarding the digital breast tomosynthesis, it involves multiple projections acquired across an arc that are reconstructed into series of stacked images. Very much true. That is what is the role of tomosynthesis is. Now, during DBT image acquisition, the X-ray tube pivots in an arc of 10 degrees. Now, 10-degree arc means 5 degree here and 5 degree from away from the midline, right? So the answer is false, because there are multiple tubes that can arch, or that can acquire images from maybe -15 to +15, even -30 to +30. So the answer to this particular question is false. In general, okay, so this was just the table which I had put to show you that there are multiple machines from maybe various companies, and the arch and the sweep angle is different for all of them. It could be as high as 50 degrees. In general, the larger angular range of the X-ray tube motion results in more tomographic information and yields better section separation over vertical z-axis. So the answer is true. The larger the arch area, the more the images, and the better the resolution or separation. The DBT imaging is associated with decreased acquisition time, however, requires a longer interpretation of time owing to the larger image set. It is false. It increases the acquisition time. Now, statement 5, compared with full field digital mammography alone, suppose we are doing only mammography, breast cancer screening with DBT, that is digital breast tomosynthesis, plus full field digital mammography is associated with increase in the cancer detection rate, ranging from 1.2 to 4.6 per thousand examinations. So definitely, as per logic, we will be aware that, okay, 1.2 to 4.6 is a very particular number, but definitely it increases in the cancer detection rate. So the answer is true logically, but yes, I am giving you the number also, that it increases the detection rate of the cancer by 1.2 to 4.6 per thousand exams. Regarding magnetic resonance imaging, in an external magnetic field, more hydrogen nuclei align with their magnetic movements parallel to the external field than anti-parallel. So this is usually the first you can say postulate which we learn that happens when we are reading about MRI. So the answer to this statement is true. Second question was, protons subject to a strong static external magnetic field start to precess in phase. So the answer is false, because protons align with the external magnetic field, but they precess with different phases, and hence they cancel each other's transverse magnetization. So that is also being told to us when we start reading about MRI. The frequency of precession, that is Larmor frequency of protons in a static magnetic field of 1.5 Tesla equals to 42.6. The answer is false. Now this is the precessional frequency in a 1 Tesla. So at 1.5, it would be proportionately, like you will have to multiply 42.6 into 1.5, so it will come to 63.9 approximately. Fourth question, at 1.5 Tesla, the precessional frequency of hydrogen nuclei in fat is 220 Hertz, lower than the hydrogen nuclei in water. So the answer is true. This is something which we have to remember, and definitely we have to multiply it with 2 if I would have given you the statement regarding 3 Tesla. Apart from hydrogen, other nuclei that can be polarized in an external magnetic field include carbon-12 and oxygen-16. Now actually what happens, these even numbers of the protons and neutrons, they do not have any magnetic vector or have a zero net magnetic movement, so they cannot be polarized. So if I would have given here as 13 carbon, then it would have, the statement would have been true. But here, apart from hydrogen, the other nuclei that can be polarized is 13 carbon, okay, not the 12 carbon. So that was the case. In spin echo and factors affecting image quality, in spin echo imaging, the first radio frequency pulse in a spin echo pulse sequence is a 180-degree pulse, so the answer is false. Rephasing of the transverse magnetization is caused by 180-degree pulse. The answer is again true, because the rephasing, or the, what should I say, that in inversion recovery also we use 180. So rephasing happens of the transverse magnetization when we are putting a radio frequency pulse of 180 degrees. Very beautifully given in one of the books, where race between rabbit and hare has been represented, right? So effects of local field inhomogeneities on MRI signal are eliminated. True, because when we are using spin echo, because of the usage of this 180-degree pulse, the inhomogeneities on the MRI signals are definitely eliminated. For practical purposes, the delay between excitation and refocusing pulse is kept constant, but signal readout can be performed at any chosen given echo time. So the answer is false. Why? Because the time to echo is always double the time between initial 90 and 180-degree pulse. So if initial distance between time between 90-degree and 180-degree pulse was t half, then definitely the t will be 1. So it is double to this particular time. Rephasing can only be performed once, and the whole sequence must be repeated to obtain another echo in the fast spin echo sequence. The answer is false. There could be, we can use multiple rephasing sequences, 180-degree pulses for rephasing, and this is actually what we are doing when we are using fast spin echo or turbo spin echo sequences. So we are using multiple rephasing focuses and getting these particular sequence. Now, regarding the types of gradient recalled echo sequences, spoiled, that is incoherent sequences allow T1 weighting. The answer is true, because if the repetition time is shorter than the T2 of the tissue, then the residual transverse magnetization remains at the time of the next radio frequency. The spoiling which we do, it eliminates this residual transverse magnetization. So that means transverse magnetization is nothing but T2 weighted, like T2 weighing of the tissue. So since the spoiled incoherent sequences spoil that, or they reduce the T2 weighted tissue weightage in the sequence, so definitely it automatically increases, or the sequence becomes more like T1 weighted. So this we have to remember. Spoiling can be achieved by pseudo-random variations in phases, that is killer phases of the excitation pulse. The answer is true, because we can do spoiling by multiple ways, and there are multiple names of the sequences. I will show you in the next particular box that there are multiple names given to these RF spoiled residual transverse magnetization pulses, that is flash, SPGR, T1 FFE. So all these things are given. The answer is true. Rewound, that is coherent GRE sequences, are useful in arthrographic, myelographic and angiographic applications. Now, as I told you that the spoiled, that is incoherent GRE sequences, they allow, or they increase the T1 weighting factor of the tissue to be put on the screen more. Similarly, coherent GRE, that is the rewound or rebound, you can say, GRE sequences are more give rise to more T2 tissue characteristics. So the water will appear white on all these sequences. So that's why they are very useful for arthrographic, myelographic and angiographic applications. Okay, so coherent sequences are insensitive to motion and flow. The answer is false, because motion and flow, they destroy the steady state on which these sequences depend, and that's why they are like not insensitive but sensitive to motion and flow. Definitely the motion and flow will have artifacts. Ultra fast spoiled gradient echo sequences require magnetization preparation. The answer is true, because due to very short TRs in these particular sequences, and in order to saturate the transverse magnetization, not only very small excitation flip angles are used, they are resulting in poor T1 contrast. And this thing can be overcome by preparation of the pulses, such as 180-degree inversion prior to the acquisition, which improves the T1 contrast between the tissue. So ultra fast spoiled GRE sequences require magnetization preparation. So definitely, just because we are using more of interventions, they require more they require magnetization preparation, just if you can remember in that way. So this is just another box which I just put from one of the articles, where these are the spoiled, that is the incoherent sequences. Siemens, it is known as flash. G, it is known as SPGR. Philips, T1 FFE, that is fast field echo. Then types of sequences, or which are the coherent ones, that is rebound or refocused or rewound sequences. They could be post excitation, pre excitation, or fully refocused, and these are the names given by different vendors using the same physics principles. Now, regarding diffusion weighted MRI, diffusion weighted is achieved by applying a single gradient pulse on a pulse encoding axis. Most of you have given it correct answer, that the answer is false, because diffusion weighting is achieved, by applying a pair of diffusion encoding gradients on either side of the 180-degree pulse at various times. Now it could be B200, B800, B500, or B1000. And that's why the answer is false, that we require two gradient diffusion encoding gradients. Second STEM question: areas of restricted diffusion show as a high signal on DWMRI. Yes, we all know, we have been seeing diffusion in and day out, that yes, areas of restriction appear high signal. Interpretation of DWMRI can be confounded by a shine through artifact. Very much true. So the effect of the diffusion gradient is to reduce the overall image intensity due to the irreversible signal loss, and therefore they may sometimes we may confuse themselves with the T2 artifact. Areas of restricted diffusion show as a high signal on ADC map. No, areas of restricted diffusion should appear inverse to what we see in the diffusion, so they should appear low signal on ADC map. A pyogenic brain abscess has a high signal on DWMRI. So true, that because of the restricted diffusion and the infection and the proteinaceous content, it appears hyper or high signal. Concerning magnetic resonance angiography, time of flight MRA is used with gradient echo sequences. True. Okay, no more explanation, because due to the time of flight effect causing flow enhancement on these sequences, it provides a good signal from the blood vessels. Time of flight MRI is not prone to slow flow signal saturation, so the answer is false, because they are prone to slow flow signal saturation, and sometimes when the flow is happening parallel to the plane of acquisition, at that time also we may have artifacts. Phase contrast angiography involves phase encoding by a monopolar gradient. The answer is false. Bipolar gradients are again used for phase contrast angiography. PCA allows imaging of the slow flowing blood. So here there is an advantage of PCA over TOF. And yes, phase contrast angiography, it allows imaging of slow flowing blood too. Contrast enhanced angiography is performed using fast gradient echo sequence. The answer is true, because we are using T1 weighted characteristics of the tissue, and we are using that to get contrast enhanced angiography. In relation to, so the questions were checked only till this point, and we could get our winners very specifically. So I did not check 16 to 20th questions for you, but definitely I'll be telling you the answers. Now, in relation to the specialized MRI techniques, perfusion brain imaging is based on differences between magnetic properties of oxy and deoxyhemoglobin. It is false. Actually, this is the basis of the brain oxygenation level dependent, that is BOLD, bold sequence, and not the perfusion. Brain perfusion imaging and functional imaging are usually performed with fast T1 weighted sequences. The answer is again false, because sequences that are sensitive to magnetic susceptibility, that is T2 weighting, are used. Areas of increased brain activity in functional bold demonstrate a reduction in magnetic resonance signal. The answer is false, because see, I'll tell you that oxyhemoglobin is diamagnetic, deoxyhemoglobin is paramagnetic. So what is happening in case of bold sequencing? There is increased deoxy, and just to fulfill that effect, there is more of oxyhemoglobin. Right. So now this oxyhemoglobin, due to its diamagnetic effect, it will have an increased signal on T2 weighting sequences than the diamagnetic. So that's why it will appear increased signal in the magnetic resonance signal. So the increased brain activity in functional bold MR demonstrate a reduction. There should have been increase in the magnetic signal. Then it would have been a true. So MR spectroscopy requires a strong magnet that provides a uniform magnetic field. Very much true, because we need to have a very homogenized field when we are trying to catch a part per million different element inside the body. So MR spectroscopy requires a strong magnet. MR spectroscopic images of 1 hydrogen, 31 phosphorus, and 13 carbon can easily be obtained in vivo. For these statement, 1 hydrogen and 31 phosphorus is still true, but 13 carbon we cannot. Spectroscopy is like quite impossible or impractical, I would say. So that's why this statement is false. Regarding artifacts in MRI, motion artifacts occur mainly in frequency encoding direction. You have to remember this, that no, it happens in phase encoding direction. So the statement is false. Aliasing occurs in phase encoding direction in 2D. Again, it is true because just like motion artifacts, aliasing also occurs more in the phase encoding direction. Magnetic susceptibility effects are more pronounced on spin echo than on gradient echo. False, because magnetic susceptibility artifacts are worse on the gradient echo, which do not provide compensation for local magnetic field inhomogeneity. So chemical shift artifacts are virtually eliminated on 3D scanners. No, because I just told you in the previous questions also that the difference between the processing frequency is varies by 220 in 1.5 Tesla, so it is around 440 in 3 Tesla. So definitely the chemical shift artifacts will be more pronounced in 3 Tesla. So they are not eliminated. Ringing artifacts can be eliminated by increasing the metric size. The answer is true, because ringing appears along the they are nothing but alternating dark and bright lines that are parallel to the high contrast interface, and usually they are happening along the phase encoding, because phase encoding has a smaller matrix we are using along the phase encoding direction, because we want to reduce the scan time, and therefore it happens along that thing. So you just have to remember that ringing games artifacts can be eliminated by increasing the metric size along the phase encoding direction. Okay, so regarding the specific absorption ratio, the SAR defines the amount of energy deposited per kilogram of the tissue by the time varying magnetic field gradients. So here the word of play was magnetic field gradients. No, it is not because of the magnetic field gradients. The answer is false. It is because of the radio frequency pulses which we are using. The maximum allowed rise in body temperature in normal scanning is unlikely to be exceeded by SAR less than 1 watt per kg. So it is true. It is usually less than 2 watts. So it is, yes, less than 1 watt. The SAR is higher in spin echo imaging in comparison with gradient recalled imaging. True, because actually in spin echo we are using more of there is more of tissue deposition, so the SAR is higher in spin echo. Just remember this much. The SAR can be reduced by using parallel imaging, so anything that reduces the scan time will definitely reduce the SAR, that is a specific absorption ratio. So yes, the answer is true. The SAR increases with repetition time. The answer is false, because longer the TR, it reduces the duty cycle, and therefore it allows more time to the tissue to cool down. So that's why the answer is false. Shorter the TR, increases the SAR, not the other way. Regarding fat separation techniques, protons in fat molecules precess at a slightly lower frequency than the protons in water. The answer is true. Definitely they precess at slightly lower frequency, as I have been told again repeatedly. Chemical shift is linearly proportional to the external magnetic field. Again true, as I explained in the previous slide. Chemical shift selective, that is CHES, fat suppression. Then there is another type, that is spatial spectral sequence and Dixon and stir techniques are all chemical shift based fat suppression techniques. The answer is false. Why? Because chemical shift, this is CHES, and the Dixon are chemical shift based fat suppression techniques. But however, the stir, as shown in this particular box, you can see that these are the chemical shift based suppression techniques. However, stir is inversion based, while spare and spur are hybrid. So they have the good qualities of both stir as well as chemical based shift suppression. But CHES and Dixon are chemical shift based fat suppression techniques. Stir is inversion based, and hybrid ones are spare. Spectral pre-excitation with inversion recovery sequence is insensitive to magnetic field inhomogeneity. The answer is false. Actually, all these sequences except the stir and the hybrid one, the Dixon, that is a 3 or the 4 point Dixon, are insensitive. Rest all the sequences, even the hybrid ones, are sensitive. So spectral pre-excitation with inversion recovery sequence is insensitive to magnetic field homogeneity or magnetic field homogeneity. So the answer is false. Most of the sequences are sensitive to magnetic field homogeneity. Spare and spur have high SNR as compared to stir. So that was the good point of the hybrid sequences, that yes, they have high SNR as compared to totally inversion recovery, that is stir. Regarding MR-based iron quantification techniques, the super paramagnetic effect of ferritin and hemosidrin creates a local susceptibility-induced contribution to the local magnetic field that results in faster decay of the transverse magnetization. Answer is true. The presence of lever iron will also lead to shortening of the longitudinal relaxation time constant. Again, the answer is true because it will lead to shortening of both T1 and T2. Microscopic fat demonstrates a decrease in signal intensity on out of phase GRE images. The answer is true because the microscope fat deposition suppose in the lever will definitely demonstrate a decrease in signal intensity in all the out of the phase, or as we repeatedly take the sequence at multiple times, we will see decrease in the signal intensity. Presence of lever iron overload will show decreased signal intensity on in phase compared with out of phase. True. This you will have to read more about the lever quantification and lever suppression techniques, and then you will come to know about this particular reasoning. Quantitative susceptibility mapping is potentially the most direct and most sensitive MR imaging technique for detection of an iron deposition as compared to T2, T2 star relaxometry. The answer is again true because quantitative susceptibility, as written in this particular, I have just put a drop box. It is beyond the time of this particular answers of the quiz to tell you about all the latest sequences. So just read these this particular article, that is latest techniques MRI sequences in radiographics, and you will find this box, and it is being written very clearly that quantitative susceptibility mapping is potentially the most direct and most sensitive sequence for detection of iron deposition as compared to the relaxometry also. So thank you very much, and I would request the organizing team to please announce the winners. Thank you again. Thank you very much for giving me the opportunity.